Okay, back to here. Okay, so we got the line, we got our point, our vector, our slider, we're making a line. Next we will extrude, so under surface and freeform, there's the extrude command. So extrude command requires two inputs, a base and a direction. What do we think we put in for base? What's that? The line. Got that, and then what do we want to do for direction? I want to go in this direction. I want to go up. Z, what is it?
Vector.
Z vector, yes. So back to the vector tab, under vector, unit Z. Here we go, like that. But now I only have this little guy. Well, how do I want it to be? I want to be able to manipulate that and make it taller. What do we think we should do?
Number slider into the factor.
Exactly, yes. We'll put a number slider in the factor. I'm just going to copy. Actually, no, I'm just going to make it a square surface. So I'm going to take this number slider, and I'm just going to also plug it into the factor. So I have basically a square surface that no matter how long it is, it's also that height. So I'm using that number slider in two different ways. Just so we can keep track, I'm going to make a little note here. You know, this will be surface. Whoop. Okay, everybody follow along so far? Got that? Okay. So now the fun stuff. So what I want to do, bless you, is I want to break this surface up. What I'm trying to create here is some sort of pyramidal shapes that come out of this surface that I can manipulate. I can open and close. Okay. So, you know, we could do all kinds of different tools to kind of break this up or figure this out. But people have already done that for us, and that's why we're going to use the lunchbox tool. So if everybody's downloaded the lunchbox, it's either lunchbox or in this L, and you'll see you have all of these different tools. And I'm going to focus on these panel tools here. So if you come over to the panel tools, you can see we can do diamonds, hexagons, quad panels, random, skewed quad, staggered, triangle, different kinds of triangles, all that kind of stuff. So you'll see if I pick one of these, I picked triangles panels C. I can plug a surface into there, right? So if I take the extrusion and plug it in, I automatically get a surface that's broken up into these triangular panels, right? So I can use other ones too. If I hide this for a second, I plug that in there, I can get hexagons, I can get random panels here, like this. So I get a random shape, a random rectangles. I can do different kinds of triangles. I can do all those on top of each other if I really wanted to. You know, you can do all these different panels, all these different tools. I'm gonna use this one here, which is, I believe, the triangles C, right? So it kind of makes a square and then separates that square into a bunch of triangles. But it kind of just automatically creates a number here. So if I hover over these UV divisions, you'll see they're both 10, you know, locally defined as 10. So that's what it's creating. It's creating 10 different U divisions and 10 different V directions. Do we remember what UV means? You know, it's a hard concept, but
I vaguely remembered it last time.
They're usually linked to a surface and similar to an X or a Y, but the 0 would be one end of the surface that you're referencing, and 1 is the opposite end. So it's trying to reference a specific point on that surface.
Exactly, yeah. So like if I was finding a point on this surface and it has a UV value, this bottom corner might be 0, 0, so 0U, 0V, and this top right corner would be 1U and 1V. And dead center in the middle would be 0.5, 0.5. So it's just a way to find a point on this surface. So what this UV divisions is saying is it's basically taking the surface and saying, I want to split this up into 10 U, like, 10 different U divisions this direction and 10 different V directions this way, or separations that vertically. So I can change that by putting something into these. What do you think we should put into the UV to change this configuration?
Well, a number slider.
A number slider. Oh, when down, say number slider. You'll probably get it right like 50% of the time. So I'm going to make a number slider, do it the fast way, 0, ... I'm going to just do it up to 20. I'm going to copy that because I want to do maybe we want to do 2 different separations. So if I plug these in, you'll see that it basically goes blank because I'm in 0. And then if I increase them, I start to get different separations. I can add a bunch. I can do very little. Like they can be the same. They can be different. But it breaks it up however we want. And this is, if this surface was a curved surface, it would do it across the curve. It's just doing it on the surface. We're doing it on a flat panel right now. We'll eventually do one that's curved because it's just a little bit more complicated when it's curved. So we'll start here and then we'll get more advanced. Everybody follow that so far? Any questions? Okay. So I'm going to, I'll copy this and give myself a little note over here. Panels. And I'm going to hide. So you'll see here, just something to note. I have this surface right here because I'm plugging the surface in. So that's here, but also this other surface is still here. They're kind of still on top of each other. They're still being like represented. So sometimes to clean it up, what I do, and you'll probably do as well, is that I'll hide things behind a certain level. So that way I'm only looking at this final where I'm at, so I don't have to see things on top of things. So I'm just gonna, to do that, I select everything, middle click the blindfold person, and then that's it. And so now we're only seeing that end bit. Okay, so now I want to be able to manipulate this, but I don't really understand what's coming out. So I'm going to place a panel, double click, type in panel. I just want to see what is coming out of this this node here. And you can see that I have a bunch of surfaces, all kinds of surfaces all over the place. So really what I'm seeing here, if I was to grab one of them, so, all right, let me put that back for a second. So as we recall, what is this? Do you remember what this is? We call this inside of a list, yes. And you'll see at the top it is 0, 0, 0, which means, and I scroll down, I don't see any other lists. There's only one list, the 0 list, and it has however many items in it, 255. So this is a list. So I just want to see what these are. I'm just curious. So I want to get one of the things in this list. Do you remember how to do that? It's a little more complicated. We're trying to get an item in the list. So we are looking for a list item. Is a node.
I can see why you did that as a
yeah. Item in a list. So we're looking for a list item. So this has a few different things. So this has the list you want to get the item from, the index, and the wrap, which we're focused on just kind of that first one and maybe the second one, the wrap less so. So if I plug this list into here, a few things you can do. We can do it the cheaty way, which I tend to do, which maybe isn't always the best. Well, it's the best whenever I'm trying to just get one thing really fast, which is if you scroll into this node, you'll see you have plus signs and a plus on top and a plus on bottom. If I click that plus sign like this, it makes this an I and this a +1. And you can keep hitting plus if you want. You can keep adding items to this if you wanted. And you can subtract them by clicking the subtract next to each one. And what this does, if I take another panel here, is this. That's taking -1, so let's do this. Let me subtract this one. The I is getting the first item in this list. So what it's doing is saying, okay, here's a list. I want to get the I item, which is basically the 0 item, that first one. And I'm going to plop it out the other side, right? So I'm just going to show you. I have 2, so this +1 is actually getting the second item in this list. And I'll show you. I'm just going to get a surface node here real fast so we can see what we're actually getting. Oop, that's not right. Should get a surface. Interesting. So, oh, it's got the text. Oh, there we go. That's weird. Oh, it's weird that it was making that text. Okay, so for some reason it was this was popping out text. I'm not 100% sure why. So I just took that panel here, I plugged it into the list, and this went fine. So you'll see what I'm getting here. Plug this one in here. Oh, that's so weird that I never knew it did that. I'm not sure why it's doing that, but I just plug this right into this surface node and plug this one into the surface node, and you'll see that I have 2 highlighted triangles here. If I click on one, this triangle, this surface, is that 0 item, right? So this untrimmed surface 0 coming out of panels, I'm getting here with I, and I'm representing it there, and it's highlighting this guy. And the second one on this list, so the one that's under number 1, is that triangle. And you can imagine if I kept going, if I hit another plus sign here, I plug that one in, I got that triangle. If I get another plus sign, I get that one, and then I'll get this one, and I'll get this one, and I keep going, right? Does that kind of make sense? What I'm doing here, how I'm grabbing those items? Yeah, let's see. Yep, Hari.
What's the node that you're using to highlight it? You say that was the surface?
This is this one right here, the one that's green.
Yeah.
So I just went into the parameters tool tab, and I grabbed the surface node, and dropped it in. I just plugged this in. It's basically a way to kind of grab, like, this is a surface, so if I grab the point node, it's going to probably give me an error. See how it gives me that error? Basically, it's saying this isn't a point. So I know it's a surface, so I'm just using the surface node to pull it out there.
I'm getting that error for surface.
Okay. Maybe you do what I did first. Yes, so you're doing what I did. I don't know why this is. So plug of the panels directly into the list and not there. And that should, there you go. I'm not 100% sure why that's happening, but you all right, Haley? You got Rhino?
Yeah, I don't remember my login to sign in to get the lunchbox.
Okay.
So I'm not doing this one.
Now you might be able to make one quick, but I don't think you need anything special to have it. Everybody else follow along? Do we understand? Yep, Martin?
It's showing up weird. It's like showing us that. It's like
What you got going on
two
there?
of these things, I'm not sure.
When do they show up? So
What's up with these?
you click on. Oh, it's just showing.
Is it just this?
That's weird that it's showing. It's interesting that it's showing that for you and not. I think it's just showing the plane. Oh wait, hold on. You're using the plane tool. So that's a plane. So you want the surface.
Oh, it's not the. Okay, it looks serious.
It looks very similar, but yeah, there you go. That's the surface.
That makes more sense. Okay.
So now if you plug that into there, and then deleted that guy, he would probably go away. There you go.
There.
Mm-hmm. Cool. Everyone else, Julianne?
I think I the same problem as Ari. Once they show up, right?
Can you zoom out a little bit? Oop.
Is it heavy?
Did I do
Is
it?
No, you're good.
Okay, yeah, this is my fault. If you zoom out a little. for some reason I don't fully understand. Normally the panel node just passes information through. I'm not 100% sure why these ones don't, but plug that panel into the list there, and now I should be good. For some reason it's passing that through as text. I don't understand. Unfortunately, I don't have the answer for that. So yeah, so see how you have the panel, instead of plugging this panel into the list, plug this node directly into the list there, and that should solve it.
Oh.
You may want to use the triangle one just because what we're about to do next might change what you're going to do. Everybody else good? Everybody following along? We're good? No questions? Okay. All right, so I'm just going to delete some of these. There's another way. So this is an easy way to grab kind of the first item in a list, which is fine for our purposes. Oop. I'm going to get rid of that one. Another way, let's say I wanted to grab, let me just screw down here. Let's say I wanted to grab like a different item in this list. Like let's say this triangle wasn't the one I wanted. Some of these other ones were one of the ones I wanted. Or I wanted to grab like every other triangle or something like that. I can use this tool here, because what these numbers here on the side mean, 25, 26, whatever, to 34, that is the index of that surface, right? So if I wanted to grab item number 34, if I plug a number 34 into there, I got rid of this. That right there is item number 34. So that triangle, if I change this, pull this back, that triangle is item number 25. Right? If I really wanted to get weird with it, and I wanted to grab like every other triangle, I could make a series of numbers. Starting at, let's say 1, or starting at 2, step 2, and I do this, 100 times. This wouldn't grab all, or I probably have to do it like over that, but I can get a series of numbers here, so you can see, you don't have to do this part. I'm just showing you an example. So this series pops out a bunch of numbers, basically gives me all the even numbers, 2, 4, 6, 8. And I can plug that into this index, and now I grab all of those triangles. So I'm grabbing every other triangle in that list. So maybe I wanted to make a different kind of pattern here. So that's another way, if I increase this slider to be like 300, so we can grab all of them. I can grab all of the other, every other triangle, or every even numbered triangle.
What is that node called again?
This one here? Yeah. This is a series node. So if you double click, type in series, and you basically plug in a start, a step, and then how many you want to, how high you want the numbers to go. So if I wanted to get like every 30, maybe that's not exactly what I wanted. I could plug this here, and I could say that gives me all of them. Step. I can start to kind of play with that pattern and find the one I want. So just another way to use this node here. We don't necessarily need it for this, but just an example, just to understand how lists work. Right, we have a list, which is a bunch of items. They're all numbered, and that number is their index. And that index, and if you use the list item tool, item node, you can plug in the list in the index, or you can use the plus minus to grab items. All right, so I'm going to go back here to just having the first item in that list pulled out. And the reason I'm doing this is because I want to focus on one of these triangles, right? I'm really going to work on all of these, but I want to start by just kind of working on just this one, get what I want to happen on this one, and then I'll apply it to all of them. It's just a little easier to wrap your mind, for me personally, to wrap my mind around kind of one instead of 200 of them, and then you can apply it to all of them. So eventually we'll come back and we'll bypass this node, but we'll do that later. Okay, so what I'm looking to do, so actually what I'll do to make it even easier is I'll hide this, so I'm only looking at that singular triangle. Okay, so what I'm looking to do here is I'm trying to create a pyramid. I'm trying to create like a pyramidal shape off of this triangle that has an elevated point out here. Does anybody have an idea how you might want to do that? So first thing I want to do is I want to find the point that's in the center of this triangle. Does anybody remember how to do that? We talked about it a little bit at the beginning of the semester. Centroid, that's what we're going to find, but there's a command that you might not expect that would find it easily.
Midpoint?
There are midpoint tools. Yeah, that's a good guess. Close. So it's area. It's a weird tool. So if you type in, it's probably an analysis. Maybe transform. Yeah, and
Trying to do with it again?
we're trying to find the midpoint of this triangle. Well, what we're trying to do is we're making a pyramid out of it. So I want like this to be one side of the pyramid, this to be another side, this to be the third, and I want triangle surfaces that come out to a point that's elevated out here. Does that make sense?
Yeah.
Everybody understand that? Makes sense? So first I'm going to do is find, so I need to find that point. Now I want to find so what I'm going to do, I'm going to walk you through before I do it. What we're going to do is we're going to find the center point of the triangle. We're going to move that center point to the place where we want the top of the pyramid to be. And we're going to create the surfaces that go to that point. And that point will be adjustable because we can move it this way. And then once we have those surfaces, we're going to create a tool that will allow me to open and close them. So, or use a command that will allow me to kind of open it. So you can imagine a facade that opens and a facade that closes based off of some parameter. So first thing we're going to do is find that middle point. And we're going to use the area tool, which is in the surface tab under the analysis toolbox there, and right here is area. And the reason we use that is because the area tool has a centroid that pops out automatically. So if I plug this surface into geometry, I get two things out of it. I get the area, which happens to be 5.347656, and I also get a point, an XYZ point that represents this point right here. So now I want to move. Now this is going to be the top of my pyramid, right? It doesn't do me any good if I look at it in Rhino. It is on that surface. It is flush to that surface. So it doesn't do me any good if it's there. So I want to move it out. So what do we think we want to do to move it out? What's that? Move. You're catching on. It's like I'm almost dropping hints on the things we need to put in here. Almost. So we're going to use the move command, which goes in the transform tab over here. And it's in the Euclidean toolbox. Here's the third over. Second one down, which is move. Drop it in. And move requires two things. It requires the geometry that you want to move and the motion, which is the vector we want to move it in. So what do we think we should put into the geometry?
Centroid?
The centroid, exactly. Plop it over here. And what do we think we should put into the motion? x vector. Is what so let's see what happens when we put the x vector in. So it moves y vector, exactly, close. So we're going to use the y vector. So I'm going to drop in a y vector here, like so. But now it's going that way. I want it to go that way. -1 in. So I'll make a slider that goes to -1. If I plug it in there, it goes that way.
So then this is negative, whatever.
What's that?
It would be just be negative, whatever distance you want. So is that
Exactly. So that's 1. If I was to slide this up to actual 1, it goes to the other side, right? So I need to have negative numbers. Does anybody remember something that I did last class that would help us?
Can you just reverse it?
Re-
reverse.
So there is, I think this will work. Oh no. I think there's actually a reverse vector tool, which allows you to plug this here, plug that there, and it'll go the other direction. So that's one thing you can do, right? So this here, if I typed in reverse, you'll see this reverse a vector is which multiplies it by -1. So we could just plug a slider. I don't want it to be that high. Just only do like 3. Plug that into the factor. I'm actually going to make this. I'm going to make these real floating numbers rather than integers, so that way it's a little smoother. So that by plugging this number slider. So what I did there, just so everybody saw, I made it I double clicked on it, and you can have an integer number slider, which is what we were making, or a floating point, which gives you the decimals. Because I'm not going to make it 1,000 feet, I'm only going to make it like a little slider because I don't want it to get too big. I changed it to this real number slider here, which is the R, which basically allows me to move it by decimals. So I plug that into the vector, and then I have my reverse vector here that goes into the motion, and now it's going in the right direction. Another thing we could have done, if you remember from last class, I'll leave it like this, but another thing we could have done is in this motion, where it says motion, if I double click, or right click, I'm sorry, not double click, I can type an expression, and I can write x times -1, which means anything that comes into that node is multiplied by -1. That's another way you could have done it. 1,000 ways you can do it. None of them are necessarily wrong, so except for the ones that don't work, then those ones are wrong. So since this guy here is important because this is basically changing the height of my pyramid, I'm just going to rename this, and I'm going to call this height. So that way I know. And sometimes the things that I want to have that I may want to change, you may want to pull down away from your script here, your definition, so that way you can find them later. As you get bigger and bigger scripts, it will be harder and harder to find them. So I'm going to actually call these number of panels, so that way I know that's where these are. And for, to beat a dead horse, I'll just do height here as well. Okay, so now we got our node going up, which is good. But now I need to build my triangles that are related to this. Anybody have an idea how we might do that?
Is there a way to connect that tangent line to a point? Or just like one side of the triangle?
Is there not just a pyramid?
There might be a pyramid tool. I'm not aware of a pyramid tool, unless you know of one. Unless you were trying to take my hint as pyramid as a.
Well, I feel like when in doubt, there's a tool.
There might be. I'm not actually sure. It could be. We could look and see if there's a pyramid tool. Pyramid. No pyramids, unfortunately. But maybe it's named differently. What I'm going to do, what I want to do, is, so I'm going to create what I would like us to do, not just me. I already have one side of my pyramid. So I'm trying to create a triangle that goes like this, right? It goes from this point to this point to this point to this point. So I already have one side of my triangle, all sides. I have that line, that line, that line. I just need to create the other two sides of my triangle that connect all the dots, right? So, but right now this is a surface, so I don't have the lines of this tool, right? So if I look at my surface up here that it's coming from, I don't have like the boundaries of my surface. I just have an untrimmed surface, right? Which doesn't give me these lines. So I need to explode that out to get the, similarly in, Rhino, surface might not work, but if you had these lines joined, you would explode them to kind of get your individual lines. It's a little different here. It's actually, let me go, oh, did I unplug somehow? Don't I? No! You wanna, here we go. We're back up and running. So everybody should have a deconstruct brep, and we're going to plug the surface into there, like so. And then on the other side, we now should have, we have three things that come out. We have faces, edges, and vertices. So you'll see your edges or your faces are just the surface, but the edges is three line-like curves, which coincidentally should be 1, 2, 3 curves, right? So if I grab a curve tool, I go to the parameters tab, and I grab a curve here, and I plug this here, and I hide these other things so that way they're not distracting me. I now have these 3 lines here. So I can use, so it's a list, right? So like we said, like I talked about, this is a list with 3 items in it, but I want to get them, I want to separate them. I don't want all 3 of them together. So what's a way to get things out of a list? What's a way to get an item out of a list?
Before that.
Oh, I thought we were getting an answer. I thought Ari was calm.
Dash lines.
Dash lines mean you have, that means you have multiple lists. So can you put a panel? Let's see what's coming out of it. See how you have more than one list? So you're still working on the whole thing. So what did you plug into the DRAM? Okay, and then where's that coming from? There. Oh, you're still doing the series here. So if you want to delete that, now you'll only, if you go back over, you should not see any dash lines. Yeah, so if you did the series thing before and you still have that up, don't use that because that's gonna screw us all up. Everybody else all following? Feel good?
You're looking for a list item.
List item, yes. So we're going to look for a list item or item list. Again, we're on list item here. And since we just have three items on our list, boop, boop, I'm just going to come down here. I'm going to click 1, 2. I'm going to have 3 nodes coming out the end, right? So if I plug my edges into list, and then I plug the first item into there, you'll see that I have that line. If I copy my line, copy my curve here, I get that one. And do it one more time. What do you think we're going to get? And we'll get the last one. So now I should have a single line coming out of all of these, which gives me that one side of my triangle. I'm going to turn my point back on here so I can see it. All right, so I'm getting close here. So I've taken my triangle, I've separated it into 3 lines, like so. Now I need to kind of draw I need to draw my other lines. All right. Are we all right? We're fine. We're good. All right, Zach. Okay. So what's a way that I can draw a line from this point to this point? Line point to point.
I forget what it's called.
This is called line.
Oh.
But it's a line from a start point to an end point. But I don't have a point. I have a line and I have a point, but I don't have a point down here.
Is there? Oh, endpoint.
Endpoint. There we go. So we can get our endpoints by double click and type endpoint. And I can pull in a curve. So if I pull in one of these curves, you'll see that I now have 2 endpoints there, right? I can do that for all of them. So I'm going to copy and paste that down, and I'm going to get endpoint, endpoint, endpoint. So now I have all my endpoints. So now I can use my line tool. So I'm going to bring my point over here. This is my elevated point. I'm going to drag this over because that's going to be part of it. And I can start to draw my other lines here. So let's just say that we'll start with the start point here and the geometry here, and you'll see that I now have a line between those 2 points. If I copy this line again, and I plug the end point into that start point, I have another line. So I'm starting to draw my surface. I'll copy this down. Now I want to grab, I already have this point here to here, so I need that one there to there, which is probably my end. So I'm going to go that to there. So now I have that triangle. And technically, I have all the lines I need, right? So I can make a triangle like this with those 3 lines. I can make a triangle like this with those 3, and a triangle like that with those 3, right? So I didn't actually need all those. I do need all of these. I don't need this guy here. I do need these. And I only needed those 2 to get all the lines that these 3 to get all the lines I needed. All right. So now I got this shape that if I go back over here to my height, you'll see will adjust with my height. And if I was to multiply it, it would adjust, but I'm not going to do that right now. So now I got my pyramid. But I don't want it to be lines, I want it to be a surface. What do we think we need to do to make that a surface?
Surface.
Just surface? It's in this. I'll give you a hint. It's in this box right here.
Boundary surface.
Boundary surface. So boundary surface allows me to put in edges, and then it'll generate a surface from that, right? So let's say I wanted to make this triangle over here. I need these 3 lines. right? So I need that line, so I'm going to plug that in here. I need this line. So how do we plug more than one thing into a node? Do you remember? Hold down Shift. Hold down Shift. I can plug that in there. I still need one more line, which is that bottom one, which is here. So I'm going to hold down Shift and plug it in there. And now I have a surface. All right? So I can do that for all of them. Is everybody following along? I see a lot of maybe confusion over here.
The one at the top? The geometry motion?
This here?
Yeah.
That's this point. That's the point we moved. So remember we made this area and the centroid over here. We plugged that centroid into a move command. We moved that up.
Oh.
So that geometry is that point that we moved. Cool? What do you want? Here, I can make this big if you want.
Can you repeat like the last like 2 seconds? The last thing that you plugged in? I missed.
Surface.
Okay, so inside of the surface tab, under freeform, there's a node called boundary surfaces. That basically takes, if I drop that and it has one thing plugged in, which is edges. So if you plug in enough edges, it will create a surface from those edges. So what I did was took all those lines that I created. Let me just take this over real fast. I found I wanted to create this first triangle, so I said, okay, I need that edge, so that's the first edge, I plugged that in. I need that edge, that's the other side of the triangle, so I plugged that in. And then I need the bottom line that we created back here, which is right there, and I plugged that in, and it gave me that triangle. Does that make sense?
Yeah.
Make this big again. Jessica, Julianne, we're good, we're good. Martin.
So those curves plug in.
They plug into this, which is called boundary surfaces.
Yeah.
So are you not following that?
Oh, there's the yeah.
Mm-hmm. Sure, no, that's getting complicated. All right, so where are we at here? So
I have multiple plugins.
okay, yeah. So don't plug in randomly. So so can we move around? I want to see your triangle you got going on here. Okay, so is your surface on the ground, like flat?
Not sure.
Can I drop you 1 second?
Yeah.
Just want to make sure I understand where you're at. Okay, there we go. Now I was trying to understand. All right, now I understand. You type that again. Okay, so we're trying to. So this part of your triangle here, zoop, zoop, zoop. That's flat on your surface. We're trying to. So we're trying to create a surface, and a surface. Okay?
Right.
So you go back over here. I'm just going to unplug these for a second. So what you need to do is keep losing Okay, there we go. Just need to understand what direction. All right. So now, first we want to do is find which line is that. So if you click on one of these guys, it's not that one. It's that one. So plug that one into edges. Okay. So now we have that one. So now we need that one. So it should be one of those. There it is. So hold shift. Oop. Okay, so now we need that bottom line. So it should be one of these guys. You're gonna plug that one, hold shift. Now you got your triangle. So now we're gonna do that 2 more times. Anybody else have any problems?
I'm kind of confused, like why you're only plugging in certain like lines, like the end, but like that, like you're leaving that one like unplugged, like the bottom.
Well, we're gonna plug it in here shortly.
Okay.
I was just trying to do one at a
I
time.
think I like kind of like
Lost it there.
the
No, sure. So that's why I like to. So what do we got? This looks a little weird. Can you unhide? Can you go back in one? That node right there. Can you preview that node again? Let's see. What is it? Alright, now go back over. So let's just pick one of these triangles. Let's say that one. Alright. So let's find that line right there. So click on one of these guys. One of these ones here. So that's one. Here.
yeah, because I saw you have like this one plugged so this still
So click on that one. That one's good. Click on that one. That one's not good. So yeah. So let's delete these two. Start fresh in here. So which one is that? That one is that. Okay. So don't
just like
okay, there we go. So can you click on, so let's say we want to create that line here, so you can find those 2 points. So can you click on that? Okay, it's not that one, it's that one. I don't know which one's which though, so it depends on how you, wait, that has all, oh, you have 2 curves plugged in. So only 1 curve per, okay, that's where we're running into problems. Move that up, and I'll just create one more of these and plug the last curve into it. So cut that one.
this and that.
This one here into that. So now we got all the possible points we can do.
Yeah, there we go.
Okay, so click on this one here. So I don't know if it's the start or end, but let's try the end. Plug that, it can be in any of them. Start, and then we want the end point to be this guy here. So that's your elevated one, so that one. Yeah. So plug that into there. Okay, so click on this, it's probably that line. Sorry, so it's not the end, it's the start. There we go. So now you need to create, all you need to do is one more line. So you need to find that point and that, wherever that point is, and all right, so it's one of those. So yeah, try that and put the geometry. There you go. So now we should have your being able to create. So now we want to create this triangle.
Yeah.
So we want to first find that line first. So which one of these is that line? That one. It's the middle one. So plug that line into edges. Now find that line. All right, that one. So hold shift. Plug that into edges, and then we need the bottom line now, which should be back in one of those. You scroll over in your thing that way. You want to use this. So you need to do that again, but do it for this one.
Okay.
And then same for the last one. Everyone good? Okay, good?
I think a full period.
Okay, so what do we got plugging into our edges there, our boundary?
Start.
Everything seems fine, but so curious.
Start of the curve.
So yours is flat. So which can you go back a little bit and unhide that node and see what direction? Okay, so your surface is. So, all right, so that's all right. So we're on the right track so far, I think. So, okay, yeah. So go to So you want to create. So you did one, right? Now you can do the other 2. So which I haven't done yet. So
Oh, you only did one.
I only did one.
Oh,
Does everybody else feel good? Can't figure it out, Haley?
No, but it was like,
Okay. Got a lot of errors over here.
Working backwards.
Working backwards, okay.
Figure it out.
Yeah. Everybody else good? Alright, so we've only created one triangle so far. So now we're going to create the other two, which is the same thing. So we're going to use the same kind of node. We're going to go to surface, freeform, boundary surfaces. But we need to find this triangle now, right? So I need to find this line. So which one is that line? I'm going to click through here. It's that one. So I'm going to plug that into edges. Now I need to find this line here. So I'm going to say it's this one. I need to hold shift, plug that one in. And now I need to find this bottom one, which should be one of these. It's that one. Shift into there. Now I have my second triangle. And I can do that one more time with this last one. So I want to find that line here. I'm going to click through. It's probably that one. Hold shift, goes there. I'm going to find this line here, which is this one here. And then that bottom one there, which is this one here. Hold shift into there. Now I have my pyramid that if I come back to my height, I can adjust height-wise of that pyramid, and everything adjusts. Is everybody? I'll wait until I have confirmation that we have achieved pyramid status. We'll put a note here so I know where my pyramids are. I know it gets a little confusing when we're like overlapping a lot. See if I can make it a little easier to follow. I don't know if that's making it any easier. Alright, I'll put it back. I'm sorry.
Can you verbally explain what points are connecting to what? Not by pointing at it, so I can actually figure it out.
Verbally explain what points are connecting to what.
Like in that last edges one.
This last edges one here. So whatever side of your triangle is not finished, assume you have two sides, right? Whatever side of your triangle is not finished, you need to find the three lines that make up that that side, right? So they should be a bottom line, which is should be one of these curves back here with a little swirly do, and then it should be one of these start endpoint, or two of them, two of the start endpoint nodes. So one of those start endpoint nodes will be one side, and the other will be the other side, and then you need the bottom, which will be the swirly do curve tool. Was that an apt description?
Yep.
Yeah, boom. Everybody else, we achieved pyramid status across the board. I can make this big again. Just so you know, you have to what I like to do is when you have Rhino up next to it, and I'm sure you know this, but when you click on them, it highlights the item in Rhino that this thing is referencing. So that's how I found, I was doing this last triangle, so I know that this one is that one line, this one is the other line, and then this one is the bottom line. And that's how I found which ones to plug in to the boundary surface.
that's not
Yeah, this isn't probably the, it can get pretty confusing. This is probably not, it started off nice and clean, but it gets a little messy right around here. Mm-hmm. Are you, did you achieve pyramid status, Ari? Something that you're doing it right. Yeah, so we don't have any boundaries. Okay. So, we create a new, let's start from scratch. Let's delete those, that those out, put a new one in. Okay, so let's pick one at a time. So can you zoom around here a little so we can see the other side? Alright, there we go. Now I see. Alright, so let's find this one. So let's build this triangle here that we're looking at face on first. So try to find that line right there. Oh, so here's your problem. You got multiple lines coming into that. Yeah, see how when you select that, you got both of those? What's happening there? Oh, you have more than one curve plugged into endpoints there. So unplug one of them. And create, make a new one of those. And plug that one in. Right, so now we separate our curves out. Oh, we may not need, actually, we don't even need that one. Then, so now try to find that line right there. Oh, because I see how you have multiple things, you don't have one plug. Oh, stop for a second. Oh, okay, so we need to recreate your line. So let's delete those two. Start from scratch over here. So now what do we got there? All right, we got one line, so let's make a new one of those. Unplug it from those. So we need to find that point. Let's find that point. Alright, so that point is in one of these. I don't know if it's the end or the start. Just pick one. And then we want to draw a line from that point to that point. Is that it? Okay, so that was that point. So let's make another one of those. And then plug your end point of there into that start. Alright, so now we have your three separate lines in 3 nodes. So now let's find that one. Right there. So plug that line into the edges. Okay, so we're making this triangle. So find that line right there. So shift there, and now find the bottom one here. It should be, I guess it's one of these guys here. Shift and put that one. So now you need to do that 2 more times, so you need 2 more of these guys. I would not copy and paste it because it's going to make you get a little confused. I would just place a new one. So now if you scroll around, you similarly find that line, and that line. I can find it all. Now you're good with that. Okay, everybody got a pyramid. We've achieved pyramid status across the board. All right. So now, last, and certainly not least, is we want to make this guy open. We want these to, imagine a facade. I'm sure you've seen them that has an open and closing effect on it. So if I wanted to make this open, what do you think I should do to these 3 things to make that happen? Rotate. There's a bunch of different rotates. So if you go to transform, I think it's in Euclidean, we can rotate, rotate 3D, rotate axis, rotate direction. Which one of those do you think we should use?
Rotate. Rotate.
Just rotate?
Rotate axis, so we can set the line to the axis.
Rotate axis. Alright, so rotate on its own. What did you say, Martin? So did you say something too?
Rotate 3D.
Rotate 3D. So we got three different things here. So rotate by itself, you need a piece of geometry, an angle, and then a plane, right? Which actually could potentially work for this because they're all on the same plane. So you could say, okay, on the X, pick the plane that they're on and then rotate from that plane. So that in theory could work. It's not the one I'm going to use, but it is possible. Rotate 3D has a geometry, angle, a center, and an axis, which isn't going to work because we would have to then find the center point of all of these that need to be rotated, which we could do, but it's a little bit more difficult. So we're not going to use that. So what we are going to use is the rotate axis, because that is probably the simplest version of this, because we have a piece of geometry, this surface. We want to rotate it, and we want to rotate it along an axis, right? So we know where the axes are because we have them as lines, right? So let's just pick one of these to start. So I'm going to delete these. So we're going to, like I said, we're going to use in the transform tool tab under Euclidean, rotate axis is the one we're going to use. So we're going to pick one of the surfaces. I'm just going to pick that one. So the surface is going to go into the geometry. And then angle. If you hover over this, you'll see rotation angle in radians. I don't know radians.
There's the converter thing. I don't remember what it's called, but I remember using it.
There's a converter. I'm not sure where it is in the tabs, but if you typed in degrees.
Something popped up.
Uh-oh. So you type in radians, sorry, not degrees. And then you can transfer. Something popped up. Okay, so you're already rotating. It's yeah, I'm not sure why yours automatically started. You must have default values. You hover in the angle, hover over angle. On I and then hover over axis. So yours is like defining one, mine's not. I'm not 100% sure. Let's see if mine. So yours has default values, which it seems like mine does, but I'm not, unless I'm not seeing it. Oh yeah, see, I have one too, which is way over there. So you can see here it automatically has values in there. So don't worry about that, we'll fix it. So we plugged in the surface. If you type in radians, there's a tool just called radians, and on the one side is degrees and the other side is radians. So what do we think we should make to plug into the degree side? Number slider. When in doubt, number slider. Double click. How high do you think that number slider should go to? 360. Exactly. So we can go, well, in theory it can go to 360, but we might not want this to rotate 360 degrees. Maybe I only want it to rotate, 45 or 90, because 360 would be, break my facade if it rotated that far. So it was a good guess, and I obviously agree with you right out the gate, but I'm going to change that to 90 so that way it doesn't go too far. So I'm going to plug plug that slider into degrees, and I'm going to plug radians into angle. And then last but not least, I'm going to define my axis. So of this surface here, I want that line to be my axis because I want it to open up. I want it to open from that point. So I need to find that line back here wherever I created it. So it should be one of these. So there it is. That's that line right there. And if I plug that into axis, and then I come down here and I rotate my if I change my degrees here, you see that it is moving, but it's going the wrong direction. So how do we flip something around? Expression. So if we right click on angle and I go to expression here, I can type in something there, and like I said before, X is whatever is coming into the node. I'm going to multiply that with an asterisk by -1. Commit changes. And now you see it's rotating outwards. So I'm going to hide this one because I already did that surface, so I'm going to use the blindfoldy do. And now you can see that I have one that is rotating outwards. So now I just need to do the same thing for all three of them. So I can copy this. Well, I won't copy it because it gets a little confusing. So we'll do another rotate axis. I'll just add 2 more of those because I know I have 3 panels. So that one's there. I'm going to use the same rotation for all of them. I'm going to pull this down. So I'm going to pick this surface. This is my new geometry. Plug that in. Plug my angle, same angle, into there. And then now I need to find that line here, which should be back here, which is this one, and plug that into my axis. And I need to do the expression again. So I need to right click on angle, expression, X, asterisk, -1, commit changes. Problems? So now I have 2 of them that are moving in and out. I'll do that one more time. Boom.
Why are you doing the expression again?
So if I don't do the expression, so I won't do the expression here. So I put in geometry, angle, and now I'll find my axis, which is that one. Beep. You'll see that this one now, well, 2 of them are rotating outwards, while 1 of them is rotating inwards.
Oh,
Which I don't want. I don't want them to rotate in the in direction. So I come back to angle, expression, X, asterisk, -1. And now it rotates outwards. So now I have a little pyramid that is opening and closing. Everybody get to that? I'll wait till everybody gets to that point. Feel good over here? Yep, we got rotation. Wait till we break our computer. We're about to break everything whenever we click the next button. So before we do the next thing, everybody should save, just in case. And this is where we're going to get to Brandon's question about grafting. Because remember, we're still only doing this to one triangle. There's like 255 of them still waiting to be adjusted. But way back earlier on in the script, we narrowed it down to just one. But we're going to open it back up to all of them so we can do it to all of them. Everybody rotate. Make this big. I feel like people are looking here.
What would you call this?
As a what?
As I'm saving it.
I just call it pyramid surface. I'm bad at naming files.
I'm not gonna have them recording.
I was gonna go 324 class.
You could do that too. I was the person in school who had like final render, I hate this project, 750, last time I'm doing this ever.
nitpicky when it comes to organizing files.
So, well, that's a good. So you
That's a good trait,
you
yeah.
should get nitpicky. I'll tell you right now. If you have good naming, I actually preach this a little bit. If you had me for Tech 5, I'll preach file naming, even though I was not the person who did that well. If you come out of school into a firm and you have good file organization and like good naming of files, your bosses will love you, because when you go on vacation for 2 weeks and they're like, where is that file that Isaac made? And if it's named like, I hate this project 566, then they're like, I don't understand what this is, but if they can find it and it's all named nicely, it'll be it'll.
If there's a gun to my head and say find sophomore year process sketch of something, I'll be able to find it in 30 seconds.
Like I like
definitely do.
in the beginning of the semesters I'm really good at it, but then after I'm doing like, let's say like one floor plan like 17 times and there's tiny minute changes to every single one, then I'm just like, I do not care anymore.
When in doubt, just date it. Dates are.
Yeah.
All my files in real life, not this is just a test thing, but in like business, every file name starts with the year, month, and day. So 2022 period 03 period 24 underscore plans. Because then it's always organized by date.
Yeah.
No matter what happens. So. Okay, so everybody rotate. We made a pyramid that's opening and closing. Yes, no problems. Are we ready to break our computers? Okay, so now we've achieved opening status on one pyramid, but we want to apply this to all of them. So back early on here,
Did you hide the surfaces?
I hit it.
Initial surfaces, not the rotating ones?
Yes, I did. So just to make it obvious, so I took these three surfaces and I blinded them, so that way I could see what I actually was doing. If you wanted to, you could hide all of this. You don't need to see all the lines and stuff.
Can you go down to like the bottom and have anything missed that?
I'm sorry, what was that?
I think I just missed that.
This open rotation thing?
Yeah.
Yeah, that's just so I know where to adjust it at. I'd probably, if I was being like Isaac, I would name everything nice, so I could remember where it was.
Is there a way to unify all of? Oh, yeah.
Okay. Love those questions. Love when I can help. All right. So, are we good, Julianne?
What did you plug into the ratings one?
So this is the number slider.
Up at like the top, or mine's showing up red. Sorry. I got it. Sorry about
Yeah, so we want to use the bottom. So it's going to be the curves back a little. So some of these are not those. So whatever one of those.
Why do you do O1 and O2?
I know, it's tough.
Tangled. Okay, yeah, I'll figure out which one's those two are new.
Well, yeah. So yeah, you didn't do those yet. So, but you can see this one is working.
Yeah. Okay, thank you.
What do you think? String O1 is fine.
We're good.
O2.
We're rotating. No more questions. Okay. So now we're ready to break our computers. At least mine, probably. So, as you recall, I'll unhide it back here. we only modified one triangle out of this field of triangles. To break my computer a little less, I'm going to change the amount so that way it doesn't, so there's not so many that it has to calculate. So you can see that this one adjusted, you know, to the right size because it's following, it's changing with it. So I'll just do that. So that way, so I would recommend doing this as well, shrinking your U and V values of the surface down to a lower amount, so that way it doesn't have to calculate so many problems. Because what we're about to do is we're going to demonstrate for Brandon why graft is important by me breaking my computer. So you may not have to do this, but you can watch what happens when I do what I'm about to do. So whenever we limited this guy down, if you all remember, so here was our surface and we got just one, let me unhide this, we pulled out just one triangle of that surface in order to just mess with just the one. But I want to apply this logic to all of these triangles. So I need to undo what I did and not bypass it. So you can see here, this is the node I used to bypass this list item. All I need to do to undo that is take this panel and plug it into that surface right there. And then that will basically, instead of taking only one item out of the list, it'll take all of them, right? So I'll do that now, and you'll see, watch it break. So now we got this, which is crazy looking. And probably have a bunch of, we have some broken nodes down here, things aren't working. So the reason that is happening is you'll see here that all of these surfaces are in a single list, right? So I just took this node here. All those surfaces are in one list. So when it's applying things down the line here, it's basically, it doesn't know, it's applying them to all of them simultaneously. So it's like trying to connect all points at all triangles to all other points in all other triangles. So what I need to do is separate those triangles out into their own list. So they're all 0 of 0, they're all in this list. What I need is a list with one item in it, and then a second list with one item in it, and a third list with one item in it, right? So, yes, there'll be the big list and minor lists inside. So what grafting does is it basically does that. It takes everything, a list of things, and then it'll make them into their own list. It grafts them into other lists, all right? So if I come over here to this panels tool, I'm gonna zoom out so we get the full effect, hopefully. When I right click on panels, you'll see that there's a graph button. And if I click that, I now have snapped into place. I'm gonna hide this again. And if I look at this list, which was before a single list with a bunch of surfaces in it, it's now, however many lists, 15 lists of single surfaces, right? And if I come down to here, I'm gonna rehide. So I'm gonna hide this as well. Oop. So I come down to my rotation, I can open them all. I can make them all different heights. And now I can bump up my number of panels and make my computer have a little bit of a panic attack. Not too many. But you can see that I can close them all, I can open them a little. Open them too far, so see, even this is too far because you can see here that it's like okay, and then they kind of pass each other, which you don't really want, right? So somewhere around, probably would want to cap this rotation at like 30 degrees, okay? So now they don't pass each other and break. But I now have a surface with these panels that I can open and close. If I wanted to, I could open them a little, beep, boop, boop, like that. I could come over here. I could bake these in, bake, bake, bake. Am I baking them? Turn on my little Arctic. Now I have a surface, a like sort of tessellated surface with openings in it. Let's go to shaded. That I can keep manipulating if I want. So you can imagine the next step of this, which we won't do tonight, is these all don't have to rotate in the exact same amount. Right? I could plug in, if you really, really wanted to, I could plug in, because if you look here, if I look at a panel coming out of one of these, you'll see that I have, similar to the other one, because I graphed it way back there, I have all of these surfaces, or all of these individual triangles are separated out into their own lists. So if I plugged in, I don't know how many there are here, 143 different numbers, which we can do a little sample. We don't have to do this, but if similar before, I made a series. Let's say I wanted them to gradually open. I'm going to start at 0. Start at 0. I'm going to step. I'll say a step of 3. So it's going to change 3 degrees. I'm going to do that 143 times. So if I put a panel here, I should have 143 different numbers. Oh, going up to that's too high. Oh, I just realized that doesn't do what I wanted to do. Let me change that. What's a better way to do that? Well, I guess I could only go up to 30. I guess it'll loop around because I only want to go to 30 degrees. Let's see what that does. So these are all. Imagine these is all different angles. I think it'll loop because I don't have enough numbers. So if I plug this into the degrees. That didn't work the way I wanted it to. Maybe I have to graph this. Here we go. So now you'll see that some of them are closed. They gradually open until they're fully open, and then it's just repeating that last number over and over again. So if I did, how would I do? What was I going to say? Can't think of how to do it right now. Oh, actually, I'll do it. I know how to do it. I'm going to make this real number. Okay, I'm going to step this down. So there we go. Now we're getting closer. So now I'm plugging in, I just made that slider a little bit smaller. So that way I could do 143 numbers. And now it's gradually opening as it goes up the chain, right? There's nothing to say that I can't take sun data and say how much sun is hitting every single one of these surfaces and then open by that factor. Or something like that, or how much wind, or how, like I said, how many times they tweet about puppies, each one opens differently, right? Yep.
So, like, what happens if I have, like, 4 different walls on several different elevations? Do I copy this and then, like...
Go ahead, sorry. I didn't mean to...
No, I don't know.
So...
Because, obviously, like, some of these, like, parameters are on X and Y and Z axes, but if you like rotate them, they get distorted.
Sure. So there's one method. It's a little less elegant, you know, but it is.
Yeah, like what if the wind's coming from the northwest? And then this isn't a map. I'm using this project as an example. So then, like other areas wouldn't be as open because the wind doesn't get through. So then it would all be good.
Mm-hmm.
I don't know. I'm just thinking.
No, so yeah, perfectly reasonable question. So this is a simplified example on purpose, right? Because this was already difficult enough to kind of grasp, right? What we would do, and I will show you a version of this. I'll do a curved version, right? So let's imagine we had a curved canopy, and we wanted to do this on a curved surface, right? As you can imagine, way back here, remember when we moved that point, this guy right here, and we moved it in the Y, you know, we just plugged in a Y vector to it, and like you're kind of suggesting, Isaac, that in imagine a project that was curved or had multiple walls. If I had a wall going this direction, that Y is the wrong direction. We really want to go X. And I had a wall going that way back there. Y is the right direction, but we want it to go that way. And similar that way, we want to go X that way, or about a roof, we want to go that way. That's when we have that wonderful word that I talked to you about a dozen times in the beginning of the semester, the normal.
Oh,
okay.
That's all making sense now.
So what we would say is, here's the surface. The normal to that surface is the normal of all the surfaces is, it could be negative. We'd have to make sure it goes the right direction, but normal is perpendicular to that surface, right? So if I had, because you can imagine how complex, that's just a box. At least that's X, Y, Z. Imagine a curve. It's like X, Z isn't, you know, if I have a curved surface, Z is not necessarily the right direction. We want that one, right? So then we plug this surface in and we get the normal of that surface. And then that's how we would move that dot. We would say, I want to move that along the normal vector. Because we've just used X, Y, Z vectors, right? Vectors can be X, Y, and Z. You know, imagine like physics when you talked about throwing the ball. And it's like it has this vector and it has an upward vector and a sideways vector which create this angle. You know, so it's a combination of X and Z. And it's X this and Z that, and it makes a diagonal, right? So we would use the normal to figure out what that vector is.
So essentially, we like created the normal, and then it's applying that to other system isn't the right word, but other like geometries.
Exactly. Yeah. So I could have done this exact same. Sorry, go ahead.
I thought it was the other way around. We created the system and we apply that to them.
Create the system and apply that to a normal.
Or you're just subbing in the unit vector, right? Or normal.
So I could probably, I would probably break it, but
Like, could we make all of this our own? Actually, I was gonna say our own like normal. Like, is there a way to like merge this? Okay, never mind.
I think, wouldn't you just sub that factor Y vector out for a normal?
Yes.
Isn't there a normal vector, and then you'd set that.
So.
Oh, and then okay,
Yeah.
that makes sense.
So what we would do, what we will eventually do, and I'll try it right now. We'll see what happens. There's this node called evaluate surface, right? So if I evaluate a surface, it'll tell me a few different things. It'll tell me a point on that surface. I have to tell it a surface. I have to tell it a point on that surface, right? This is when the UV come into play, right? And then it'll pop out a normal. Okay, so let's see if we can't screw everything up. So the surface that this all is based off of is back here, I believe. Yes. So if I plug this surface into there, I need a point that is. Also need a point that is on that surface. So I need to. It can't just tell you the normal of the surface. It needs to tell you even though this surface has a singular normal, it doesn't know that yet. I need to tell it what point do I want to. Let me hide some of this other stuff. What point do I want to evaluate? Just hide this for a second. Hide all this. Show that again.
This is like an incredibly small script, isn't it?
Oh, this is pretty small. Yeah. You guys will make much bigger ones.
Dang. Why'd you say that?
All right, so here's our surface, right? So I plug that surface in. Coincidentally, I have a point that I know is on the surface back here, but I started with a point. So I'm just going to use that as an example, but I could use any point that's on the surface. So if I plug this into here, this should go gray. If I plug in a panel here, and I pull out the normal, it's just going to tell me Y. See, it says X, Y, Z, it says 1, Y. So I can replace wherever that,
Right there.
this it right here?
Yeah.
So I can replace this so I'm just going to get a vector node so I can I don't really need it, but I'm going to plug this in. I need to multiply. How do I multiply? I gotta remember for a second. Hold on. Because if I just plug this in, it's going to be 1, but I want to add the factor to it. I'm trying to remember that for a second. Vector amplitude. There we go. So this will allow me to kind of, this is another way to, I'm just adding a factor to this vector, so I'm multiplying it. This is another way to do it, which is have an amplitude. So I'm going to plug this, I can just plug this directly into here. And then I can plug this into here. So these two things should have the exact same value. So see how they both have 0.18, 1.1817, 1.817. So now I can plug this into here. And then if I go back to this, everything should still look the same. So that I didn't need to do that because it's a simple surface and Y is Y, and I didn't need to figure that all out. But you can imagine if I had multiple surfaces, we could try real fast. Try another thing, see what happens if we can't break it. So I'll make another surface going that direction, right? So going the opposite way. So I'll put in, I'm going to copy this direction. I want it to be Y. You guys don't have to follow all this along. This is just me entertaining myself.
You have a Drake shaper.
See what?
You have a Drake shaper here.
Why?
Graduated 2 years ago or something.
Okay.
And all this advanced modeling and Grasshopper scripting reminded me of something he posted where he created a script that if you draw a line in Rhino, it'll make a studded and drywall wall. Plan.
Oh yeah, sure.
A video of it. He posted like him drawing a line, and then just automatically creates a studded wall. That's cool.
No, yeah, it's awesome. Yeah, that's awesome. That's really cool. So now you can see I made another line here that's going the opposite direction. This might break it, so let me save this. I'm not exactly sure how this is going to pan out, but I'm going to plug this into here with that. Yep, that broke something for sure. You shouldn't model this way. You shouldn't make it and then try to, jam this back in afterwards, but surface extrusion. So let me graph this. There we go. So now you can see that it's going the wrong direction. See, these are going inwards instead of outwards. So I would need to figure out how to fix that, which I don't know how to do at this very moment.
You can't just expression the.
I have to separate out these
I see.
because these are going the right direction,
Right.
and these are going the wrong direction. So I would need to understand what that means for all of them. Actually, this actually screwed something up because you can see those are flat now. That one's correct. But, yeah, I'm not exactly sure how to fix that. Either way. So I broke that one. But if I was to plan this from the beginning, I would have probably not done some of the things that I did. But you get the point. So, like I said, I just I'll delete that. Now it's the same, back to normal. So yeah, you have to use. That's when you have to think about scripts sometimes. Like I did this one easy on purpose to know that direction, but when it gets complex, you need to kind of evaluate parameters, and so you understand the direction you need to go and all that kind of stuff. But this node here, these few nodes, they essentially the same thing as that Y one, but it just looked at the surface and said, go this direction. But yeah. So
Crazy, especially if like a curved surface. I was thinking about this when you did the normal, like a curved surface, something like this. It's just like evaluating basically every single point along that surface and finding its normal, and then like, it's kind of wild to think about.
yeah, I mean, that's what it's good at. You know, that's why it's better at doing these calculations, these dumb calculations, than you are, faster than you are, right?
I'd say better too.
Maybe better. Well, you created it, right? So you're the one that's actually better, right? It doesn't. It's only as smart as you make it. You know, you are the one who has to embed the knowledge in there. But I'll try to do, maybe for next class, try to do a version of this that instead of rotation, it evaluates the sun. You know, it's like how much sun is hitting this thing. I'm going to open or close based on that value.
You could also do that off of a tractor point, right?
Sure.
Yeah.
I can put, all this is number. Just remember, all these are numbers, right? So all I'm doing, I'm telling it degrees, but I'm just plugging a number in here. And this was just a list of numbers, So I could do an attractor point, which evaluates how close, the point is to these different points, and then adjust the degrees based off of that.
I know we had another class, his class was trying to, their assignment was to generate random IPOs.
IPOs. Yeah, and the other, like one of these vizzes? Yeah, the other viz. Yeah.
But it was like they're trying to create some sort of responsive thing to all this random stuff. So they were talking about like the amount of times, or the amount of people that get allergies or something during this season, like random input and output.
Well, coincidentally, that's your assignment for Tuesday, which is it's a little late, so I probably won't go over the case studies yet, unless somebody has something desperate they want to share with everybody. So as I discussed a little bit about the assignment is you are going to create projects based off of some sort of script, right? And you need to evaluate something. So you need an input. So some piece of data that you're analyzing, you need to. So in here the input might be The input is really this rotation, but it's just random. But let's say it was the sun. The input is how much sun is hitting a facade. The process is all of this stuff. You're taking that number and you're evaluating it through this system. And the output is a facade that shifts based on the sun, right? I would like it if we didn't all do sunshades, like I said. And do something more interesting. I'll try to show you some more interesting things. But we'll figure that out. So your assignment for Tuesday next week is to come up with 3 input processes and outputs. So not actually modeling anything, just saying like my input is going to be this. I'm going to process it like this, and I'm going to output is going to be a canopy, or the output is going to be a bus stop, or the output is going to be, so you may.
You have to write what the entire process would be.
No. So just like, let me think of an example. The input is the sun. The process is shifting the facade based on how much sun is hitting a given point, and the output is a facade that has an opening flower shape, right? Or the input is how many times people tweet about puppies. The process is taking that amount and creating a color based off of the amount of tweets that come out, and the output is a facade that changes color based on how much people are talking about puppies.
Does it have to be a facade or architecture?
It doesn't have to be a facade, so it's going to be similar scale as the previous project. It's going to be like an installation of some sort. So
it is architecture.
It's architectural, spatial, we'll say. Doesn't have to be a building. So it can be a building if you want it to be. But it's something that people can experience. So we'll think of it more as an art installation that is spatial in some way. So the assignment is for all of you to come up with 3 of your own. And then by Tuesday next week, we're going to figure out groups, because like I said, it's going to be a group project. And then by Thursday next week, your groups will have come together and nailed down what they think their input process output will be. And then you'll get started. We don't really have that much time left in the semester, so. Does that all make sense? Everybody over here feel good? I feel like I got this as the quiet side. Okay, well, that's it for now, unless somebody's like, I need to show this cool case study I found, but everyone's packing up, which makes me feel that that's not the case. So I will, I'll look at the case studies and I'll see what are interesting, and maybe we'll talk about those on Tuesday. All right. Thanks, y'all.
Like 6 more hours.